If step one and step two do not work, meaning if you're not able to simplify, or the simplification of the integrand is very complicated, or ordinary substitution, both of them don't work, then there are several things, several strategies that you already learned. Look for the expression inside the integrand. What kind of functions is it? Is it made up of trig function? Then you will have to apply. Is it a combination of sine or cosine? Or is it a combination of tan and secant? Or is it a combination of cotangent and cosecant? Which exponent is odd? Which exponent is even? So you learned how to integrate trig functions in section 7 too. So you may have to apply those techniques. Or sometimes whether the integrand is a rational function. If it is a rational function, whether you are able to resolve into partial fractions and do the integral. Are you able to factor the denominators, a denominator of the rational expression, rational function as product of linear factors or product of linear factor and quadratic factor? And this was discussed in section 7.4, resolving into partial fraction and integrating. Then in section 1, we also did integration by parts, IBP method, where you find out by Liarte mnemonic whether the function is made up of logarithmic and algebraic, or algebraic and trigonometric, or what kind of functions the integrand is made up of. Can we apply integration by parts method? That is one option. Then does the integrand uh, involve radicals? So is it of the form square root of x squared plus or minus a square, or plus or minus x squared plus or minus a square? And we did this in trig substitution. And does it have not just a square root, but any nth root of ax plus b type? Whether the substitution works by rationalizing and making the substitution u equal to nth root of ax plus b. So these are the other strategies that uh, you may want to apply if simplification of the integrand and the ordinary substitution don't work. So then again, if none of them are leading to a possible solution, then try again. If the first three steps have not produced the answer, then there are only basically two methods of integration: substitution and by parts. Try substitution, and then you will have to try by parts. And sometimes you may have to manipulate the integrand, meaning rationalizing the numerator or denominator might also help. So to do that, we will try a problem where we manipulate the integrand. Okay, this is done by manipulating the integrand. So look at the expression 1 over, look at the integrand, which is 1 over 1 minus cosine x. So if we keep like this, then we need sin x on the numerator if we have to apply some kind of substitution method. As we don't have sin x on the numerator, we can consider multiplying and dividing by the conjugate of the denominator, which is 1 plus cosine x. I'm pretty much multiplying the given expression by 1, so I'm not changing the given expression. That is 1 plus cosine x on the numerator divided by denominator is of the form 1 minus cosine x times 1 plus cosine x. It is difference of squares. So 1 square minus cosine square x. Or it is 1 plus cosine x over 1 minus cosine square. This is nothing but um, sine square x from Pythagorean identity. Now, We are going to write the integrand dx divided by 1 minus cosine x in the revised form that we have got 1 plus cosine x over sine square x. Now we can break the integrand into two parts. It's 1 over sine square x plus cosine x over sine square x. This will become cosecant square x. Reciprocal of sine is cosecant. Okay? And plus, so we can write this one as, we can actually break this into two integrals. One like that. The second integral is cosine x over sine square x px. This is I. So integral of cosecant square x is negative cotangent x. You might have seen that in the formula, or derivative of cotangent x is negative cosecant square x. So if you notice here, this one, integral of cosecant square is negative cotangent x. So um, this set of formulas that you have, these are basic ones. It's strongly recommended that you memorize them, because otherwise you won't be able to derive each time when you get such a step in the problem. So it will be just a part of the problem. So you may want to just memorize those. So it is equal to negative cotangent x. Then for this part, I'm going to call it I1. And then I'll show you how to integrate that second part, which is this integral equal to I1. So we are going to get to this step and substitute I1. So let us evaluate I1. So I1 equal to integral cosine x over sine square x dx. This can be done by ordinary substitution. You just call u equal to sine x, substitute u equal to sine x. Then du would be cosine x dx. For I1, the numerator is cosine x dx, which is cosine x dx, which is equal to du. Denominator is u square. Sin x the whole square, sin x equal to u. So it is integral u to the negative 2 du. So by power rule, it is u to the negative 1 over negative 1 plus a constant. So it is negative u to the negative 1, but u equal to sin x. So it's sin x to the negative 1, or it is 1 over sin x. Then we have to remember to add the c at the end of the problem. So substitute this over here. So I equal to negative cotangent x plus I1. I1 is 1 over sin x. Don't forget the c because it is indefinite integral. Hope this video helps.